Okay, well, I'm afraid that COVID has still got its grip on me, so it's another video introduction to today's lesson. We're going to look at tree diagrams today, which is a way of representing probabilities. It's a grade B question. It's generally straightforward to revise and practice. It could come up on a paper 1 or a paper 2. The methods you're going to use would be the same on both. The examples that I've got in this little booklet I think are all paper 1. So the key facts you need to know. So they're a good way of showing combinations of 2 or more events. Each branch in the diagram is labelled at the end with its outcome, and the probability is written alongside the line. So we'll see that when we build one in a moment. When travelling from left to right along the branches, you will find yourself using the word and. And in probability, if you use the word and, if you're anding the events, then the probability you produce is from a multiplication. So if you're anding, you're multiplying. If you can travel along more than one path from left to right, then you are ORing. So you would then add these probabilities. So the word OR in probability is associated with adding, and the word anding, which in arithmetic you would add, but in probability you multiply. So let's get a context going here, and I'll come back and hopefully make more sense of that. So a game involves 2 bags, each containing coloured balls. Bag A contains 1 red ball and 4 yellow balls, and bag B contains 2 red and 1 yellow ball. 1 ball is drawn at random from each bag. Draw a tree diagram to show the possible outcomes. So we have 2 events here. The events are going to be drawing a ball from bag A and then drawing a ball from bag B. And each event has got 2 possible outcomes. When I pull a ball out of bag A, I'm either going to get a red ball or a yellow ball. So my first event is bag A. My possible outcomes are either red or yellow. And the probability of me drawing a red ball is going to be 1, the number of possible red balls there are in the bag, divided by the total number of balls in the bag, which is 5. So the chances of me getting a red ball out of bag A is 1 out of 5. And then the chances of me getting a yellow one will be 4 out of 5. And on a tree diagram, the total probability of the branches in an event need to add up to 1. So 4/5 and 1/5 add up to 1. So that's fine. So that's the first event. The second event for us is bag B. And we can get to bag B in 2 ways. We could either end up having already drawn a red ball from bag A, and then either a red or a yellow from bag B, or we could have ended up with a yellow ball first, and then our possible outcomes would be down here. So this is the event bag B, and there's 2 ways we can get there, either from red first from bag A or yellow first. Now bag B contains 2 red and 1 yellow, so in total there are 3 balls, 2 of which are red, so that will give me the probability 2/3, and this would be 1/3. So again there, my total possible outcomes for that event would be 2/3 plus 1/3, 3/3. And then these probabilities are then repeated on this final set of branches, because we only come down here if we've started with a yellow. So those are the total possible outcomes from my game, my event, drawing 1 ball from bag A and 1 ball from bag B. Now, to come back up here, if I'm travelling from left to right along the branches, I am anding. So if I am travelling red and red, and I reach this point here, then that means I'm getting a red ball from bag A and a red ball from bag B. So I multiply the probabilities. So that would be 1/5 multiplied by 2/3, which is 2 times 1 over 5 times 3. So I got a 2 in 15 chance of getting a red from each ball. If I end up at this point here, that means I've got a red ball from bag A and a blue ball from bag B. So this would be red and blue. And that would be 1/5 and times 1/3, which would be 1/15. If I get this point, that means I've got a yellow ball in bag A and I've taken a red ball out of bag B. So this would be probability yellow and red. So that would be 4/5 times 2/3, which would be 8/15. And finally, if I reach this point on my tree, I've gone yellow out of bag A and what have I got there? Red and yellow, red and yellow. Why is that a blue? That should be yellow, shouldn't it? Yellow, 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 yellow. Okay, sorry about that. I'm sure you were all shouting at the screen. So red, yellow, yellow, red, yellow, yellow. So probability, that's still wrong. That should be yellow and red. So red and red, red and yellow, yellow and red, yellow and yellow. So that one's going to be 4/5 multiplied by 1/3, which will be 4/15. So those are all the possible outcomes from taking a ball out of bag A and a ball out of bag B. Now I've written those out for each possible point on the end of my tree diagram, just so that you can see how those calculations are formed. You don't need to do that in an exam question. You will just need to find the appropriate branch or branches that will answer your question. So what is the probability that both balls will be red? So probability red and red means you start in here, bag A will be red and bag B will be red. So we've got the answer up there anyway, but if we hadn't written all that out, I would have just had to write down here 1/5 multiplied by 2/3 equals 2 out of 15. What is the probability that they will be the same colour? So with the same colour, that means there's more than one way of achieving this. It means you could either have red and red, or yellow and yellow. So this is the example with this bullet point. If you can travel along more than one path from left to right, then you are ORing. So you would add these probabilities. So I'm either going red and red, which is 2/15, or I'm back to the start, yellow and yellow. Now I've already worked out those answers up there, but in case I hadn't, we'll write it out again here. So red and red, well, I have worked that one out, so that's 2/15. Or means add yellow and yellow, which would be 4/5 multiplied by 1/3. So that will then work out to be 2/15 or 4/15. And when you add fractions, the numbers at the bottom have to be the same before you can add them, and then you just add the numerators, the numbers on the top. So the chances of both being the same, of them both being the same colour, is 6 out of 15. Okay, so hopefully you can see what's going on here. So let's take a look at another one. Excuse me. So this one's got a slight twist in the tail, just so that you're reading the questions carefully. So it's important you read the information in the question very carefully before transferring the detail onto a tree diagram. Consider the example below. Sally and Laura sit their driving tests. The probability of Sally passing her driving test is 0.7. The probability of both Sally and Laura both passing is 0.56. Complete a tree diagram to show this information. So we've got two events, Sally sitting her test and Laura sitting her test. So if we say that the first set of branches are Sally, well, Sally is either going to pass or she's going to fail. If she passes, the chances of that happening are 0.7. So because these branches need to add up to 1, then I can work out that the chances of her failing are 0.3. Then we come to Laura, and Laura is going to pass or fail as well. And if we read this, it tells us the probability of both Sally and Laura passing is 0.56. Now, if you're not switched on here, the most common mistake to make is to write 0.56 there. But that's not the 0.56. The 0.56 is what we get here, where we've got pass and pass. And that is 0.56. So 0.7 times something must equal 0.56. So hopefully, just thinking of your tables and your 7 times tables, 7 goes into 56 8 times, so that is going to be 0.8. 7 eighths are 56. So 0.7 times 0.8 will be 0.56. Okay, so you need to be careful that you pick up on that if that is what they're going to give you. Now that I know that that is 0.8, that then must be 0.2, which means that must be 0.8 and that must be 0.2. Calculate the probability that A, both women fail. So probability F and F. So on my tree diagram, that means Sally is going to fail and Laura is going to fail. 0.3 multiplied by 0.2 equals 0.06. If you're not sure whether it's 0.6 or 0.06, multiply the digits. 3 2s is 6. Count the number of digits after the decimal point in the question. 1 2. That means there will be 2 digits after the decimal point in the answer. Only Laura passes. So if only Laura passes, then that means Sally is going to fail and Laura is going to pass. It's going to be fail and pass, which would be 0.3 times, don't need that bracket, 0.8, which would be 0.24. 3 8 to 24, 2 digits after the decimal point in the question, 2 digits after the decimal point in the answer. And C, only one of them passes, would be probability, so Sally pass, Laura fail, or Sally fail, Laura pass. Which is what we've already worked out. So that's going to be pass and fail, 0.7 times 0.2, or is add, and F and P we've already done is 0.24. 7 2s are 14, so that would be 0.14 plus 0.24, which is 0.38. Okay, so once you've copied that through that, if the cover supervisor can pause the video clip, and then what I want you to do when they've done that is to have a go at the questions that follow, which are all past paper questions, and I will then work through the answers for the rest of the clip, and the cover supervisor can take you through the clips if they need to. Might be able to work it out themselves. Okay, thank you, supervisor. If you want to pause now. Okay. Each time George fires an arrow at a target, the probability that it hits the centre of the target is 0.3. George fires 2 arrows at the target. Complete the following probability tree diagram. So it hits the centre, does not hit the centre, first arrow, and then the second arrow. And each time the probability that it hits the centre is 0.3, which means that must be 0.7 for those to add up to 1. And then the second time he fires the arrow, the probabilities are unchanged. So that will be 0.3, 0.7, 0.3, 0.7. Calculate the probability that George only hits the centre of the target once. So he's either going to hit and miss, so probability hit and miss, or miss and hit. So hit and miss will be 0.3 times 0.7, or means I'm going to add them, and then miss is 0.7 times hit 0.3. 0.21 plus 0.21 is 0.42. So the chances of him only hitting the centre once is 0.42. Question 2. Bethan sometimes gets a lift to and from work. When she does not get a lift, she walks. The probability that she walks to work is 0.9. The probability that she gets a lift home from work is 0.4. Getting to work and getting home from work are independent, so they don't affect each other. Complete the following tree diagram. So you can see here that the first event is how she gets to work, and then the second event is how she gets home. So these branches have to add up to 1, which means the chances of her getting a lift to work must be 0.1. On the way home, it's 0.4 that she gets a lift, which means it must be 0.6 that she doesn't. 0.4, 0.6. So 2 marks for completing those. Calculate the probability that Bethan walks to work and gets a lift home. So walks to work, 0.9, and means times, gets a lift home, so walk, lift. 0.4. 4 nines are 36, 2 digits after the decimal point means there's 2 digits after the decimal point in your answer. Calculate the probability that Bethan gets a lift to work but does not get a lift home from work. So she gets a lift to work but does not get a lift home from work. So that means she gets a lift in but she walks home. So we're going that way and that way. So 1/6 is 6, 2 digits after the decimal point, 0.06. Question 3. At breakfast, the probability that Melanie has a bowl of cereal is 0.3, and the probability that she has a slice of toast is 0.2. Melanie having a bowl of cereal and Melanie having a slice of toast are independent events, so one doesn't mean she has to have or not have the other. Complete the tree diagram. So she's got 0.3 of a chance of having a bowl of cereal, which means 0.7 chance no cereal. The probability that Melanie has a slice of toast is 0.2. Has a slice of toast 0.2. Not toast 0.8, which means that is going to be toast and that is going to be not toast. Find the probability that Melanie has a bowl of cereal and a slice of toast. Has a bowl of cereal 0.3 and a slice of toast 0.2. 2 threes are 6, 2 digits after the decimal point. Question 4. The probability that Daisy wears a bracelet is 0.7. The probability that Daisy wears a bracelet and wears a necklace is 0.63. So this is one of those that you have to be careful. For Daisy, wearing a bracelet and wearing a necklace are independent events. One doesn't affect the other. Find the probability that Daisy wears a necklace. So if we look at the diagram here, I've got 0.7 for that. So the chances of her not wearing a bracelet is 0.3. The chances of her wearing a bracelet and wearing a necklace is 0.63. So this point here is 6.63, and I need to work out what that is there. So 0.7 times something is 0.63. If you bimble through your 7 times table, hopefully you will get that 9 sevens are 63. So 0.7 times 0.9 is 0.63, which means the probability of her wearing a necklace is 0.9. Okay, so with this particular question, they've really come up front to make you realise that. Sometimes that's all disguised to trip you up. So if that's 0.9, that's 0.1, that's 0.9, that's 0.1. Find the probability that Daisy does not wear a bracelet and does not wear a necklace. So does not wear a bracelet and means times does not wear a necklace. 1 times 3 is 3, 2 digits after the decimal point. Done. So then the final question. Alwyn often drives from Bangor to Cardiff. He always chooses one of 2 routes for these journeys. He either travels through Rhyadr or through Hereford. The probability that he travels through Rhyadr is 0.7. Sometimes he decides to stop for a break during his journey. His decision is independent of the route he takes, makes no difference which way he goes. The probability that he travels through Rhyadr and stops for a break is 0.42. Complete the following tree diagram. So Rhyadr 0.7. If he's not going through Rhyadr, he's going through Hereford, and those two have to add up to 1. Then we need to be careful. The probability that he stops through Rhyadr and stops for a break is 0.42. So that's the outcome of Rhyadr and stopping for a break. So that's R and yes is 0.42. So 0.7 times something is 0.42. Hopefully you're rattling through your 7 times table, which is every example has been, and 7 sixes are 42, so that must be 0.6. Once I know what that is, I know that that must be 0.4 to add up to 1, 0.6, 0.4, 4 marks. Calculate the probability that Alwyn travels through Hereford but does not stop for a break. Probability Hereford and no. So 0.3 multiplied by 0.4, which is 0.12. So those are grade B probability questions on tree diagrams. We will see some more of those examples after Easter as we're working through past papers. As I mentioned, all of those were non-calculator, but they do come up on the calculator allowed. Usually how that makes it a little bit trickier is the numbers that you are multiplying together could be a mixture of fractions and decimals, but you'll have your calculator with you, so that won't cause you any problems. And also sometimes you have more than two branches on your diagram. So it might, in this example, it could have been Rhyadr, Hereford or Abergavenny, for example. So you'd have a third branch. Okay, so hopefully that went quite well, and hopefully I'll see you later this week.